Ladies and gentlemen and non-binary members of the 27th International Conference on Image Processing, Computer Vision, and Pattern Recognition, good morning, afternoon, evening. My name is Ethan Lee, and today I am here to present a paper titled Fall Detection in SoccerNet Data, authored by myself, Jonathan Sturdivant, Brian Alvarez, Savitha Rachuri, and Dr. Gulistan Dogan from the Department of Computer Science at the University of North Carolina, Wilmington. In recent years, there has been a growing interest in fall detection research, primarily focusing on the elderly and medical environments. However, falls are not exclusive to the elderly population. In fact, studies have shown that falls during sporting activities account for a significant proportion of falls experienced by young adults. Understanding and detecting falls in sports can have important implications for injury prevention, performance assessment, and even game analysis. I am excited to present to you a look at detecting fallen players in soccer and explore the methodologies that make this possible. SoccerNet Data Set is a benchmark for action spotting in soccer videos. The action that we are focusing in this paper is fall of the players on the soccer field during a match. Falls are the leading causes of injury. However, research on fall detection has tended to be focused on the elderly and in medical environments. Falls are not a risk that only affects the elderly. In a study of young adults, 48% of young adults reported falling at least once in the previous 16 weeks. Of those falls, over a third of them were a result of sporting activity. The SoccerNet Dataset fall detection task is to predict whether or not a person has fallen in a given video. The data consists of video footage of soccer matches, and the task is to classify each frame as either containing a fall or not. The SoccerNet dataset is a large-scale dataset for fall detection in soccer. It consists of over 1,000 hours of video footage of soccer matches. The dataset is challenging due to the variability in the appearance of falls and the fact that falls are often not the focus of the camera. The dataset we are using is the SoccerNet Tracking Challenge dataset. This dataset contains 110 different 30-second clips of soccer games recorded from a single camera angle. For our detection, we intend to use pose estimation and player tracking to create a deep learning model. In 2022, the SoccerNet team has organized a challenge on 6 vision-based tasks which have corresponding datasets. Action Spotting Dataset, which contains long, untrimmed videos of action timestamps. Replay Grounding Dataset, which contains action videos shown in a replay. Pitch Localization Dataset, which contains videos of line and goal elements. Camera Calibration Dataset, which contains data representing various camera parameters. Player Re-Identification Dataset, which contains videos of the same players across multiple views. And Multiple Object Tracking Dataset, which contains videos on tracking players and the ball. We focus on the multiple object tracking dataset, where all the players present in each individual frame of the video are detected. The purpose of our research is determining whether a person or persons have fallen in multi-frame videos specific to sports is to expand the research in the field of human falling. Currently, most related research on falling has been a naturalistic observation approach of the elderly in senior living facilities or retirement homes, as persons aged 65 and above are the most likely to fall. However, despite sports activities being the second leading cause of falls, research is scarce. The studies on falling in sports tend to utilize health logging devices and accelerometers measuring heart rate and movement to track the performer. The use of the machine and deep learning remains only tapped in the falls of the elderly. Fall detection could be an important application in the sports video research, as it can be used to identify if a player has been fouled or not. Additionally, fall detection can also help to identify when a player is tiring and may need to be substituted out in order to prevent them from becoming too fatigued and increasing the risk of injury. Hence, our study will examine the accuracy of deep and machine learning as a viable solution to predict if a person has fallen while performing a sports activity. Then, hopefully, apply our studies to determine a sports-related fall in real time. Fall detection research is largely in three groups: wearable-based models, video-based models, and hybrid-based models. Some vision-based models use a pose estimation model in a deep learning model to classify video into not fall or fall categories. One such paper is Person Fall Detection System based on video stream analysis. In the mentioned paper, Mamchur and others used PoseNet to generate joint key points and utilized a sliding window to handle the temporal aspect of the task. They achieved an F1 score of 0.90. Heinrich et al. Used multiple cameras to match generated pose estimations to an individual and do fall detection for each individual in the frame, and achieved a F1 score of 0.925. Other vision-based models use features based on depth images as input. Kong and others use depth images to create a histogram of oriented gradients and trained the model on the altered image and had an accuracy of 0.98. Remaining in the field of video-based model, Espinosa and others explored a 2D CNN model with a dataset of 42,000 images of 38 x 51 pixels broken into a 2:3 and 1:3 ratio of training and test data to detect an elderly person's fall. Experimenters trained data with the Atom Optimizer and 50 epochs, resulting in an average accuracy of 95%. More sports-related, a study by Zhu and Yan in 2022 at Auckland University of Technology used non-intrusive computer vision, applied OpenPose and YOLO to archived ski videos of skiing and falling, and recorded skiers' consecutive actions to detect if a skier fell. Zhu and Yan's model performed with an accuracy of 87.20% and a 0.94 mean average precision. For our experiments, we used SoccerNet's tracking dataset. The tracking dataset was created for multi-object tracking and bounding box prediction. The dataset is comprised of 230-second video clips of live soccer matches taken from a single camera at 25 frames per second. The dataset was intended to be used for a challenge where models are created to track the locations of players on the field over the entire video. We chose this dataset because the videos were made friendly for bounding boxes as well as the single camera angle. Of the 200 SoccerNet videos, we used 15 for our experiment. Our first attempt at this problem was to create a pipeline that generates bounding boxes for each player, then take the sub-image around the player and generate a pose estimation of the player in the sub-image. We first found the bounding box surrounding each player using the YOLOv3 multi-object detection. Once the bounding boxes were created, we filtered the list for objects that were detected to be human and for objects that only contained a single player. Then we generated pose estimation was generated using Google MediaPipe API, and we included key points for a player's nose, left and right shoulder, and left and right knees. However, this was flawed as this pipeline struggled to generate the poses on players who had fallen correctly, often failing to classify any poses at all. The pose model was much worse at finding key points on fallen players, and since they are the target class, we decided to take a different approach. Once we realized our first plan was not working, we changed plans and decided to create a CNN to classify falls. We took our bounding boxes generated by the YOLO model and cropped the images to just the area within the bounding box for each player. We then took each of the sub-images and resized each of them to 150 x 150. We then used transfer learning from the Seption model trained on the ImageNet dataset. We then added a dropout layer and trained the model on our dataset. From our research into modeling our data, we found the following elements to provide us with the best results, being 89% on the training set and 90% on the validation set, and a training loss of 0.28 and validation loss of 0.33. See Figure 3 and Figure 4. We also found a decrease in overfitting and an increase in validation accuracy from foreign data not similar to the training set, from using the Seption model, a model trained on millions of pictures of objects and people, to train our model. From testing with different learning rates, 0.1, 0.01, 0.001, 0.0001, 0.00001, we found the learning rate of 0.00001 to be the most optimal in terms of converging to a specific accuracy, 89% in our case. Then, to reduce overfitting, we input a dropout layer 0.8. Afterwards, we compiled our data with Atom Optimizer and binary cross entropy as our loss function, since our output is either in 1, fallen, or 0, not fallen. Finally, when we fitted the model, we set our epochs to 200. Thus, in summarization, we used Seption to increase the prediction of falls, learning rate equals sign point 00001, dropout layer equals sign point 8, optimizer equals atom, loss function equals binary cross entropy, and epochs equals 200 to arrive at our highest accuracy of 89% on the training set and 90% on the testing. Our 90% accuracy on the testing set means that our model performs moderately well in determining whether a person has fallen in a single-camera video of soccer matches. With further research, we believe we can increase the accuracy of the validation set and expand its usage to other non-used videos recorded on single-camera soccer matches by gathering more videos in our training set and completing feature extraction on the pose estimation data of the players on the field. Eventually, with a far more reliable and applicable method, we could apply our detection to live data, live soccer matches. Another further study is to add falling and non-falling videos of other sports, like American football, basketball, and skiing, in the training and validation data sets to broaden our model to detect falls in different sports.